Let's look at some details of the winter monsoon macrostructure. As we have already talked about before, the wintertime ITCZ over the Indian Ocean is over the south, and the winter monsoon of Australia has the anticyclone which is has this outflow towards the Indian Ocean, which then crosses off across the equator over here. So you can clearly see the anticyclone there, and the summer monsoon, of course, is associated with the okay, let me make sure I have it right. Yes, okay. So the this region is got these northeasterlies which are related to the wintertime cooling, and the big question here is, when we look at the Siberian high pressure, it's the deepest high pressure in the world compared to especially the other land high pressure centers, or North America or even Australia and so on. So what makes it such a deep cyclone? We will see that the anticyclones, which are related to the radiative cooling and the related pressure buildup at the surface and the outflow that results, are got some unique structures, and they keep pumping what are called winter surges into the low latitudes, some of which can be related to westerly wind bursts over the West Pacific, which are related to interactions with El Nino, claim to strengthen the El Ninos, etc. We have mentioned that before when we were looking at El Nino. Looking here at the topography in gray and darker gray colors, you can see the Himalayas and Tibetan Plateau up here, and the Siberian High, which is shown with this essay. Hong Kong is shown here, and Darwin is shown here. These are the various pressure contours, and you can see that here it reaches more than 1030 hectopascal, which is really the highest anticyclone pressure center you get. So we are going to look at the associated variability here. This is the Siberian region. You can see that the variability of the pressure during this year, from October 92 to February, end of January of 93, is really high, reaching well into the 1050 hectopascal range, which is quite deep. Actually, deep is used for low pressure systems, I guess, so quite high. Whereas the Hong Kong pressure, you can see in the winter, remains around an average of 10-12 or so, with a little bit of variability around it. And there is corresponding 2-meter temperature over Hong Kong, which is fairly flat, whereas the range of the temperatures over Siberia are much larger, with a cold, deep temperature here at 2 meters, corresponding to these high pressure variabilities. And if you look at the Havemuller diagram over the same time period, going from the equator to 60 north, you can see that these cold surges travel down all the way into the equatorial region at fairly high speeds, from 10 to 15 meter per second, and we will see that the dynamics of the Siberia, why it gets so deep, is pretty unique. With the radiative cooling, just with the radiative cooling, you cannot explain such high pressures. It turns out that because of the surrounding orography, it has a hard time adjusting the outflow and the geostrophic adjustment over this radiatively cooling anticyclone. So the gravity waves that are originating from the high pressure and the variability that we see here end up propagating along the topography as edge waves or Kelvin waves and so on. We haven't used the word edge waves before, but basically that corresponds to vorticity balance as well. And under certain conditions, when you have actually we used it in the ocean when we were trying to explain Kelvin waves and edge waves. So they are literally what we are saying. They are pressure buildup against orography and the energy propagating in a direction as waves in the appropriate direction as waves, depending on the pressure gradient and the so on. Okay, so these cold surges are pretty common in winter from Australia and from the Siberian high. So quickly looking at the limitations on central pressure, one dynamic constraint on central pressure is the maximum outward directed pressure gradient that can exist in an anticyclonic circulation. In a cyclonic circulation, the pressure gradient can get pretty tight all the way to the center, whereas in an anticyclone the pressure gradient is slack or not very strong at the center. For balanced motions where pressure gradient is orthogonal to isobars, we have the balance equation, kind of a rotational flow around the high pressure. V squared over RC, where RC is the curvature of the pressure surfaces, plus Fv, the Coriolis term, equals minus del phi or del n, which is 1 over rho dp dn. So it's the pressure gradient that's driving the outflow and has to balance the Coriolis and the centrifugal force, right? For balanced flow around the high pressure system, pressure gradient is positive from the center out, obviously, whilst it's negative for cyclonic flow, as we know. Solving for V in the previous equation, we get V equals minus F over 2 plus minus F squared RC squared over 4 plus RC over rho dp dn to the 1/2. There are limitations on the pressure gradient within the high pressure system we consider here. The limitation is that dpdn has to be greater than rho f squared rc over 4, essentially to balance the pressure gradient and the curvature of the flow and the Coriolis effect. Basically, you are still talking about this is sometimes called, as opposed to geostrophic balance, this is sometimes referred to as cyclostrophic balance. Okay. Oops. I omitted some details here, but essentially it turns out that just the balance between the radiative cooling and the observed pressure high of more than 1030 hectopascal cannot be explained simply by this one-dimensional balance. You will need this pressure gradient balance to explain why the pressure gets so high in the Siberian region, and that gives us these special winter surges that can come all the way into the tropics, and they are associated with all kinds of interactions in the deep tropics that are associated with rainfall and so on and so forth. Okay, so we will leave it there. You can read up the further details in the papers that are referenced in the caption of the figure. But if you understand the dynamics that winter monsoons are related to land cooling, basically cold temperatures, clear skies, radiation loss, which is the main dynamics over most regions. The special thing about Siberia is that some special dynamics is related to the orography in the neighborhood that creates special excessively high pressures at the center that are not seen anywhere else. Okay.